flipping physics. Today we'll be learning about the conservation of energy.
Oh, what is the conservation of energy?
Great question. The conservation of energy is, according to physics, energy cannot be created nor destroyed. The conservation of energy can be written as the sum of all initial energy is equal to the sum of all final energy. Let's head to the demonstration.
As you can see, energy transfers from the pusher to me and to the cart.
If energy is conserved, then why did you stop?
A great question. This is because while the cart moved, energy was transferred from kinetic energy to thermal energy. And some of this thermal energy went into the floor and the wheels of the cart. So yes, while energy was conserved in the entire system, that would be comprising of the floor, wind resistance, the cart and the person pushing the cart. When it comes to just the cart, it did not have the same amount of energy it started with.
Oh, so I see. Energy didn't just disappear, it was transferred from kinetic energy to thermal energy.
All right, now let's move on to the example problem. So here is the example problem. Take a quick look. So, a 7 kilogram baseball made of tungsten is on an 80 meter tall hill. At phase 1. Phase 2, it rolls down the hill to 10. Phase 2, it's 10 meters off the ground. Phase 3, it rolls back up 50 meters off the ground. And stage 4, it is on the ground. What is the speed of the ball at positions 2, 3, and 4? So first,
So, you need LOL diagrams. So, in all of these, there's the ball, gravity, so Earth, and the track. So, we'll have, there's the gravity here, gravity. And then kinetic, because this is really the only thing to worry about in this. Thermal, obviously we're not marking because there's no friction in this problem. All right, so in the beginning, all it is gravity. Then it goes to all kinetic with some gravity. And you continue this here, gravity, kinetic. Now it's less gravity and more kinetic. Here, continue that. And at the end it is pure kinetic. So as you see, it goes from gravity to kinetic and throughout the way, it slowly shifts. We define 2. All right. So as you can see, E.g., energy of gravity, potential, has to equal kinetic energy. Mass times gravity times the height is equal to 1/2 mass times velocity squared. So we plug in the numbers, 7, 10, force of gravity, 80 minus 10 for the height, from 1 to 2, equals 1/2 mass of 7, velocity squared, which is what we want to find, velocity. Do some numbers, multiply, crunch the numbers, you get
37.4 meters per second is the velocity. So at 2, it is traveling at 37.4 meters per second. All right, and before we move on, it is important to remember that this is a frictionless, I know we didn't write the problem, but it is a frictionless surface, and air resistance is negligible. So here's how we can find the speed at position 3. So at position 3, gravity and kinetic energy are acting on it, as well as kinetic energy. So we set them equal to each other, conservation of energy. So mass times force of gravity times height plus 1/2 mv squared equals 1/2 mv squared. Put in numbers, right? So mass 7, force of gravity 10, height we subtracted, it's -40, as down is positive in this equation. We subbed in here too, 1/2, 7, 37.4, that answer from earlier, squared, equals 1/2, 7, v squared, and this is the v that we need to find for this one. So now we sub it in, right? Add these together, multiply, divide, square root, crunch the numbers. It should be 24.47 meters per second. It's kind of hard to see there, but 24.47 meters per second is its speed at position 3. All right, so we have found 2 and 3. Now we need to find 4, the speed at 4. This is very easy, just like how we did 3 and 2, okay? All right, so look close here. Just like with before, e.g. energy, gravity, EK, kinetic energy is EK, kinetic energy. And now put in what the equations for each of them. Put in the numbers, right? 7, 10, gravity, 50, plus, again, 7, 24.47, the answer from earlier, equals 1/2, 7, velocity squared. Multiply, all the basic algebras. That in, crunch some numbers, and you will get 39.984 meters per second as the final speed. There we go. We have solved for the speed of the ball at 2, 3, and 4. And the speed, of course, at 1 is 0.
Why at position 2 is it potential energy gravity equals kinetic energy, but at 3 it's completely different?
Great question. This is because from 1 to 2, which is what we're solving for position 2, the ball starts from rest, so there's no kinetic energy acting on it. However, when solving for 2 to 3, there is an initial velocity, and therefore kinetic energy is acting upon it, as it is just rolled down from position 1. This is also why 3 to 4 is the same as 2 to 3. Now you know the rules of the conservation of energy and how energy works in equations like this. Thank you for learning with us. I enjoyed learning with you.
Do the Mario, swing your arms from side to side. Come on, it's time to go. Do the Mario.